Nikki, why are you spinning so fast?
I was running at constant speed. You slow down because you are run out of breath.
Coming up. No! Don't tell me you're drinking carbonated drinks after a run.
It's not carbonated drink. It's isotonic drink. Bonus, 100% refill the energy that lost during the exercise. So then, what do you usually drink?
Ta-da! Although it looks plain, it quenches my thirst in a matter of seconds. Also, it has no calories at all.
But isotonic drink gives us more energy.
Oh, really? You wanna bet?
Based on this scene, let's just see who can run faster after consuming isotonic drink and also mineral water. These are our participants for the experiment. First, they will be drinking mineral water before running 100 meters. The time taken for each participant to finish the 100 meters run will be recorded. After the heart rate returns to normal, they will consume 100 plus before taking off again.
In this experiment, the null hypothesis states that there is no difference in mean between the time taken for participants to sprint 100 meters when participants drank mineral water compared to 100 plus before the run, while the alternative hypothesis states that the participant who consumed 100 plus before the race took a shorter time to sprint 100 meters as compared to when participants consumed mineral water.
This is the data recorded from the experiment. This column is the time taken for 20 participants to run 100 meters after consuming mineral water. And this is the time taken for the same 20 participants to run 100 meters after consuming 100 plus. This column is variable 1, while this column is variable 2. On the data, click the data analysis. Find t-test paired 2 sample for means. Click OK. Variable 1 range, drag from variable 1. For variable 2 range, drag from the variable 2. The hypothesized mean difference should be 0. The output range can select anywhere and then click OK. Adjust the cell. Mean for variable 1 is this value, while mean for variable 2 is this value. Variance for variable 1 is this value, while variance for variable 2 is this value. The degree of freedom is 19 as n minus 1. The t-statistic is this value. The p-value for the two-tailed test is this value, while the t-critical value is this value. The confidence coefficient for variable 1 and variable 2 are 2.093. For the standard deviation, we use the formula STDEVA followed by the value of the variable. For the margin of error, we will times the confidence coefficient with the standard deviation and divide it by the square root of the sample size. As for the upper bound, add the mean and the margin of error. For the lower bound, subtract the value of the margin of error from the mean. In conclusion, the p-value is less than the alpha value, which is 0.05. Therefore, the null hypothesis is rejected. This is because there is a strong evidence stating that there is a distinct difference in mean between the time taken for participants to sprint 100 meters when they drank mineral water compared to 100 plus. From this experiment, we can conclude that 100 plus boosted the running performance of the participants. Didn't I told you 100 plus works better?
Alright.